but I'll be on it always, always and
Hi, welcome back to the Pink Chemist. So today we are going to go over how to identify molar mass, okay? So before we jump into our examples, I'm actually going to do a quick overview about how to look at the periodic table and to identify your molar mass. Okay, so I'm going to use hydrogen as the example. So you usually see H, which is the element symbol. And then above that symbol is typically a number, and that number is considered the atomic number. Okay. And then below the element symbol is another number that is usually in decimal form, and that number is our atomic mass. All right. Now, the atomic mass is the same as our molar mass. This is going to be the key number in helping us to identify our molar mass as we go over our examples today. So I just wanted to show you that way when you're looking at your periodic table, you're able to identify where to look for your atomic mass. Okay, so let's get right into it. So our first example, we're going to use CaF2. Now at the bottom right hand corner of our screen, you will see that I have set up a list of steps to consider when trying to identify the molar mass. So our first step is to separate our elements. So we're going to separate our elements. So we have Ca and we have F. Okay. Then our second step is to identify how many of each atom is present. You're able to do that by looking at the subscript. So for Ca, we have 1, and for fluorine, we have 2. Okay. So fluorine, as you can see, has the subscript 2. Our third step is to multiply our atomic mass by the subscript of each atom. So when I look at my periodic table, I know that the atomic mass for Ca is 40. Now, we're going to round to the nearest whole number. So I'm not going to keep it in decimal form. You can if that's what your instructor has instructed you to do. But here I am going to just round to the nearest whole number. And so for fluorine, it is 19. Okay. So when I multiply this, 1 times 40 is 40, and 2 times 19 is 38. All right. Once I get that, I am going to add these numbers together. And when I add these numbers together, I get 78. All right. And the unit for molar mass is grams per mole. So G/mol. Now, if you do not put the units, your answer is incorrect. You must put grams per mole when identifying your molar mass. Okay. So let's do our next example. So our next example, we have Ca3, PO4, 2. Now in this example, we have a subscript that's on the outside of the parentheses. Now this is where people usually get tripped up, but if you pay attention, you will never get tripped up again, okay? So again, we're going to adhere to the steps. So we're going to go ahead and separate our elements, okay? So we have Ca, we have P, and we have O, okay? So we separate our elements, and then we're going to identify how many of each element is present. So we have 3 Cas. And now here, instead of jumping right into saying, oh, I only have 1 phosphorus. Well, that is not true because this subscript 2 being on the outside of the parentheses lets me know that I have to distribute it to the subscripts that's inside of the parentheses. So I'm going to distribute this 2 to that 4 as well as to that invisible 1 that we do not see there for phosphorus. So I know that 2 times 1 is 2, so that gives me 2 phosphorus, and 2 times 4 is 6, which gives me 6 hydrogens. Oops, sorry, it does not give me 6 oxygens. It gives me 8 because clearly I don't know my multiplication. So 2, 4, 6, 8. It gives me 8 oxygens. All right. Now, I am going to multiply by my atomic mass. So my atomic mass for calcium is 40. For phosphorus, it's 31. And for oxygen, it's 16. Okay. So 3 times 40, you pull it up on my calculator really quickly. 3 times 40 is 120. 2 times 31 is 62. And then 8 times 16 is 128. All right. Once I get those numbers, I'm going to add them up. So 120 plus 62 plus 128 gives me 310 grams per mole. That is my molar mass for Ca3PO42. All right. So we're going to do one more example. All right. So in this example, I'm actually going to use a chemical word problem. So we're going to have copper 2 nitrate. Now, I know it's very tempting to look at this and say, okay, well, I have copper and I have nitrate. But it's very important when you have an ionic bond that you actually turn it into a chemical formula so that you can identify how many of each element is present. So copper, the symbol for copper is Cu, and I know with the presence of my Roman numeral that that's my oxidation number for copper. All right, and then nitrate is NO3, -1. Nitrate is a polyatomic ion, so that is how we know that it is NO3, -1. All right, so then I'm going to go through a process called swap and drop. So you see that oxidation number? I am going to take that number and I am going to swap it where that arrow is pointing. Okay. So once I swap and drop, I am going to have Cu, NO3, 2. All right. Now it's time for me to find my molar mass now that I have written my chemical word problem and turned it into a chemical formula. Okay. So I'm going to separate my elements. So I have Cu, I have N, and I have O. Okay, so I have 1 copper present. Then I'm going to distribute that 2, just like I did in the last example, to the subscripts that's inside of the parentheses. So 2 times 1 is 2, so I know that I have 2 nitrogens, and 2 times 3, now this is 6. Okay, now I'm going to multiply these numbers by my atomic mass. So copper has an atomic mass of 64. Nitrogen has an atomic mass of 14, and oxygen has an atomic mass of 16. 1 times 64 is 64. 2 times 14 is 28. And 6 times 16 is 96. Once I get those numbers, I'm going to go ahead and add them up. So 64 plus 28 plus 96 is 188 grams per mole. And that is my molar mass for copper 2 nitrate.
Don't play with it, don't be dishonest. Ay, still not